Recursion is maybe one of the most confusing subjects in computer science. If you get stuck at any point, keep studying the examples and try to find some more examples until it sticks for you. The idea here is to create a function that calls itself. Here is a really basic example in pseudocode. This code doesn't do anything interesting, but it shows the main parts of a recursive function. First of all, a recursive function needs to call itself at some point. Second, a recursive function needs a base case. You can think of a recursive function kind of like a while loop in some regards. You keep going through some code again and again and again until you hit some exit condition. In a recursive function, the base case is like the exit condition. It lets you know when you need to stop. Without a nice base case like this, you could get stuck in something called infinite recursion. That means your code keeps calling itself and executing again and again and again and again and again, but because you never tell it when to stop, it just keeps going infinitely. The third thing a recursive function needs to do is alter the input parameter at some point. If you aren't altering the input parameter or giving yourself some condition for changing every time you iterate, you'll never really know when to stop. And again, you end up in the same bad place with infinite recursion. Okay, now we're going to go through an example. This is the code that we're starting with, and on this side I'll write out each major line that we execute. So we're going to start by calling the function with an input value of 2. We'll start with this if clause. Since our input value is 2 and that's greater than 0, we move on to the else part. We start by evaluating this before we assign anything to the variable output. Okay, so input minus 1, that's just 2 minus 1. So we're going to call this function again, but instead with an input value of 1 and not 2. So this is the really confusing part. Your computer knows that you still haven't finished that initial call with the input value of 2. You're just jumping into this part without finishing. In its temporary memory, it'll remember that. However, it essentially makes a copy of all of this initial code, and you have to do it again, but this time with an input value of 1. I put an indent here to signal that we haven't actually finished this initial call yet, but we're just doing a call inside of that right now. Okay, so let's do this again. This time the input value is 1, but that's still greater than 0, so we can skip down to the else block. The same thing happens a second time. Before we assign anything to output, we have to do this recursive statement. This time the input value is 1, so 1 minus 1 is 0, and we have to call this recursive block again, but with a value of 0 instead of 1 or 2. Again, I indented to indicate that we still haven't forgotten about the fact that we never solved this and returned anything, but we do need to move on and start executing again. Alright, let's do this again. So this time we actually have something interesting here. The input value is 0, so we never get to execute any of this else block. We're just staying up here. We return 0, so we see it pop up over here. Now that we've actually returned something from one of our calls, we can forget about this recursive with an input of 0 and go back to that recursive with an input of 1 that we were looking at a minute ago. Alright, so we returned to having an input of 1. We evaluated this statement to 0, as I indicated over here. Again, remember, we called the recursive block, we returned 0, so now we say that this whole thing evaluates to 0, and we can assign 0 to output. Great, now that call we did where the input was 1 actually has a return value here, which is 0. So now we can kind of forget about this recursive block and move back to that original call where our input was 2. Okay, so back to the original call. This call, which used to be recursive with an input of 1, got evaluated to 0, so now we can say 0 is equal to output. And again, we can return 0, and now even our initial call is done. Great, so the initial call returns 0. Recursion can be really confusing because you start out with just this one method, but you don't even know how many times you'll end up calling it. When I'm trying to think through how a recursive function works, I'll often write out a table or a list of steps like this, so I can keep track of my values every time I hit the recursive block again. I always used to think of it like my computer was just going on tangents. I started with this initial function, and then I kept calling something else and doing something else and doing something else and doing something else, and eventually I would get back to the thing I was talking about originally. Remember, your code is going to go through these lines of code in order. It's never going to assign this output any number until you've hit the recursive block as many times as you need. Remember to be really careful when you're writing recursive code. If your base case doesn't make sense, you could end up doing infinite recursion. Let's say we change this base case just a little bit. All I did was get rid of the less than or equal to and replaced it with just equal to. Now, this code is going to run fine if we give it an input value of 2 or 1 or 4 or even a million. But if the input value was actually less than 0, this code's never going to return. If you start out with -2, you'll skip the if block and you'll just keep subtracting 1. Next time, your input's going to be -3, then you'll subtract 1, -4, subtract 1, -5, and so forth. If I use less than, though, if my number initially is -2 or -50 or -1,000,000, I'll stop as soon as I hit the base case. Remember to think about all the different input values your recursive statement could have. Lastly, if you're really not sure what your recursive block is doing, you can use print statements wherever necessary. By printing out intermediate values, you'll get a sense of exactly what your code is doing at exactly which steps.
You've been busy learning here, building up your knowledge and skills through your nanodegree work. But what's actually happening inside your head to enable this growth? Well, each time you think about something, you activate particular neural pathways in your brain, and that activation strengthens the pathways themselves. As a simple example, if I just learned basic addition so that I can figure out that 3 + 2 = 5, the more I do problems similar to this, like 1 + 6 = 7, the easier it will be for me to remember how to add digits together. Essentially, we grow our knowledge and make it easier to access the more we recall relevant information. Research also shows that applying new learning in different contexts makes it even stronger, and it allows you to retain it better. So if I move from problems like 3 + 2 = 5 to trying out something like 4 + 20 + 1 + 6, I have the opportunity to apply my addition skills in a new context, with bigger numbers and more things to add up. This will make my brain distill the core concepts necessary for understanding how addition really works, which means that in the future, when faced with even trickier addition problems, I'll have a strong foundation to tackle those challenges. This is exactly what we want to prepare you to do, albeit with much tougher problems. Our job at Udacity is to help you build deep knowledge and flexible skills that you can apply to all sorts of novel problems in the future. In order for that to happen, your brain needs to actively engage with problems, questions, and ideas that will push it to grow in the desired direction.